Assalamualaikum warahmatullahi wabarakatuh and good afternoon. So today we're going to continue on tutorial for chapter 3 AC power analysis. So for this question, if you look at the figure 11.70, we need to find the power factor, average power delivered by the source, the reactive power, the apparent power, and the complex power. So to find the power factor from this circuit here, so we need to find the ZT, the Z total impedance total from this view here. So ZT we can write down as 2 plus 10 minus J5 parallel with 8 plus J6. So this is parallel, and if you need to do this first, make it parallel first, calculate the parallel value for this 4 elements, and then you need to plus the 2 ohm resistor over here. Okay, so from this you will get 2 plus 110 plus J20 over 18 plus J. Okay, so the total ZT will be 1.152 plus J 0.768 ohm, or in rectangular form you will get 8.188 angular, 5.382 degree. So this is the last value. So you have to change it to the rectangular form because you need to find the power factor, which is we refer it to this angular degree here, where PF is equal to cos 5.382. So if you calculate, you will get 0.9956. So if the value is positive, the power factor is basically lagging. Okay, yeah, you need to remember that. So the next question, to find the average power delivered by the source. So average power is basically the real power. So this is B and this is A. Real power, which is we refer it as P. So we can get this value P real power from the complex power. So to find the complex power, which is S, we can use VI star, or because we already know the value of the voltage and also the impedance, the total impedance, we can use V square over Z star or conjugate. So V, we need to get, we just get the magnitude of it because it's a magnitude, and Z we refer to this part here because it's conjugate, so it will be negative lah. 1.88 angular, negative 5.382. Okay, so this become negative because there's a conjugate here. So from this value you will get 31.26 angular, 5.382 degree. Okay, so for this, from here we need to change it to the what rectangular form. So this is polar form, this is rectangular form. What I said before is different, sorry. So change it to rectangular form, you will get 31.12 plus J 2.932. Okay, So this is last value. So P you will get 31.12 watt, and Q you will get 2.932 VAR. Okay. So now basically you already answered the question number C. Okay, the reactive power. So Q is the reactive power, while P will be the real power. Okay, and then we need to find the apparent power. Okay, so the apparent power basically is the magnitude of the what we call the complex power. Okay, so this will be the apparent power value. Okay, this one is this one is this. Okay, and then lastly is the complex power. The complex power basically is this one. Okay, so the unit I forgot to write it down is VA. Okay, so the real power in watt, the reactive power is VAR, while the complex power or the apparent power, the value is VA. Okay, so let's look into another question. So for the next question, 120 volt RMS 60 Hz source supply two loads connected in parallel as shown in figure 11.89. So we need to find the power factor of parallel combination, and second, calculate the value of capacitance connected in parallel that will raise the power factor to unity. So the first thing that you need to do, basically we cannot simply add the power factor of each load, but we need to find each load of its complex power. And we added the complex power, and then we need to after that we will convert it to get the total combination of the power factor. So the first thing that we need to do is to find the apparent power first lah. So we'll solve load 1 first. Load 1. So S1, so we can use the equation power factor equal to P over S. So so S1 we can know that P over PF. So P they already gave it here, the value 24 kilowatt, and PF is 0.8, and then for this you will get 30 kilo VA. Okay, and then we need to find Q1. So Q1 should be equal to S1 sine theta. Okay, S1 30k sine theta. Here we need to calculate from the power factor theta. So theta cos theta equal to 0.8. So theta should be equal to 36.87 degree. So we just insert this value over here. So this is kilo, and then you will get the value of 18 kilovolt VAR. Okay, so we have these two values here, S and Q1. P and Q1. So we can get the value of complex power. So complex power as, we call it bulk as lah. Complex power equal to P plus JQ. So P over here 24k. So this is 24k. 24 plus JQ, which is this one, 18 kVA. Okay. Next we find the load 2. So look through the same process, we need to find the apparent power first. So S1 equal to P over PF. So P is 40K over PF or 0.95. So this one you will get 42.105 kVA. And then from this S apparent power we can get the reactive power, where S1 sine theta. So theta here we need to convert using the similar formula like this. So cos theta equal to 0.95. So theta should be 18.19 degree. Okay. So we added the value inside. So S1 is 42.05K sine theta 18.19 degree. So from here, the reactive power you will get 13.14 kVAR. Okay. So for the complex power, the bulk S2, we will get P plus JQ. So P is 40K plus JQ, the reactive power 13.144 kVA. Okay. So to get the total complex power, we just add S1 plus S2, where if you add it up, you will get 640 plus 24, 64 plus 13.1144 plus 18, you will get 31.44. This is J kilo VA. Okay. So you change it to the polar form. So for polar form, you will get the value of 71.17 angular, 25.95 degree VA. Sorry, kVA. So to get the power factor, so we just use this value here, where power factor is equal to cos theta, where cos theta is this one, you will get 0.8992 lagging. Okay, so I hope you understand how to get the power factor of a parallel combination. So for the next question, we need to find the capacitance value that will raise the power factor to unity. Okay, right now we already calculate the total power factor for this circuit. The power factor right now is 0.8992, where the theta is basically 25.95 degree. So we can use the formula C equal to QC over omega V square RMS. Okay, so we can find W, where W is equal to 2 pi f, where the frequency is 60 Hz, and VRMS already given in the question, which is 120 volt RMS. And now we just need to find QC. QC basically we can use formula P tangent theta minus tangent theta 1. So this is 2, this is 1, divided by WV RMS square. Okay, so tangent theta 2 basically is the original PF, power factor, and tangent theta 1 basically is the one that we need to calculate, which is unity. So unity basically the value of theta here is 0 lah. So this is theta 2. So unity theta 1 equal to 0. Okay, so we just insert all the value into this formula. P is the real power, the total real power that we calculate before is 64 tangent theta 25.95 degree minus tangent 0 degree divided by 2 pi f is 60, and V RMS is 120 volt RMS square. So here if you calculate, you will get the value C is 5.74 millifarad. Okay, so hope you understand this. Just use the formula C equal to QC over W omega V square, V RMS square. Okay, so you just need to remember the equation. So for this next question, we need to find the complex power absorbed by each element. So if we look at this, we have resistor, capacitor and inductor. So we need to find the complex power of each this element here. And you also gave a voltage source over here. So basically, if we have a voltage source over here, so the voltage across these two branches basically the same with this voltage, because this branch here is parallel to this source. So for example, we put this is as I1 and this is I2. So I1 we can calculate it as V over R. V over Z. So V, we know that A angular negative 20 degree. Z is the impedance total of this element in this branch here. So it should be 4 minus J3. So from here we get I, so this is I1, not I2 I1. This we get 1.6 angular 16.87 degree ampere. Okay, for I2 the same, the voltage across this branch is the same because it's parallel to the source. So 8 angular minus 20 degree divided by the impedance at this branch here, which is J5. So you will get I2 is 1.6 angular negative 110 degree ampere. Okay, so once you get this value, the current value of each branch, so we can get the complex number of each element. So S is equal to I square Z. So you can use this formula here. So for example, for this capacitor SC, so I, the current that flow through this capacitor is I1. So we just get this value here, 1.6 square. Z is the impedance of the capacitor, which is minus J3. So we get the value should be minus J7.68 VA. Okay, so for power complex power for resistor, the same, using this equation, 1.6 square times resistor 4, you will get the value of 10.24 VA. And lastly, for C, for complex number for inductor, the same equation, 1.6 square times the value of the impedance J5. So this you will get J12.8 VA. Okay, so now we get all of the value for each element. So that's all for tutorial this week. So see you next week. Assalamualaikum.